In this episode, we focus on human oversight, but not the kind that turns AI into a slow, frustrating process where every output needs a manual stamp. The goal is risk-based human oversight, which means you decide where humans must be involved based on how risky a situation is, how likely harm is, and how big the consequences could be. Beginners sometimes hear human oversight and picture a person reading every model output forever, but that is not realistic, and it is not the best way to manage risk. Oversight should be designed like a smart safety system, where low-risk tasks flow smoothly and higher-risk tasks trigger stronger checks. AI stays safe and useful when oversight is proportional, because usefulness requires speed and scale, while safety requires accountability and careful handling of edge cases. The heart of Task 20 is learning how to place humans in the loop in a way that reduces harm without killing the business value that motivated AI adoption in the first place. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with a plain definition of oversight that fits AI systems. Oversight is the set of human decisions and reviews that guide, approve, and correct AI behavior when the system's output could create meaningful impact. Oversight can happen before an output is delivered, after an output is delivered, or both, depending on risk. Oversight also includes how people respond to unusual behavior, how they handle user complaints, and how they decide whether to adjust the system. A beginner misconception is that oversight is only a review step, but oversight is also governance in action because it defines who is accountable when the system causes harm. If you cannot answer who is responsible for approving certain uses and for intervening when things go wrong, oversight is weak by definition. Risk-based oversight strengthens accountability by matching responsibility to impact. It also supports learning, because human reviewers can notice patterns of failure and push improvements that automated controls might miss. Risk-based means you start by classifying how risky the use case is, and the easiest way to understand that is to connect risk to consequences. A low-risk use case might be generating internal brainstorming ideas that are not shared externally and do not drive decisions. A higher-risk use case might involve customer communications, where a wrong or insensitive response can harm trust. A very high-risk use case might involve decisions that affect people's opportunities or well-being, such as access to services, financial outcomes, or health-related guidance. The higher the consequence, the stronger the oversight should be, because the cost of a failure is larger. This does not mean you must stop high-risk use cases. It means you must design stronger guardrails and stronger human involvement. Beginners should see risk-based oversight as choosing where to spend human attention, because human attention is a limited resource that must be focused where it matters most. Another dimension of risk is uncertainty, meaning how reliable the model is for the task. Some tasks have clearer right answers and can be validated with strong tests, while other tasks are fuzzy and depend heavily on context. A model might be highly reliable for summarizing a well-structured document, but much less reliable for interpreting ambiguous human intent or predicting outcomes. If reliability is low, the system should require more oversight, because the chance of subtle failure is higher. Uncertainty also rises when the system is used in new contexts, such as a new user group, a new data source, or a new language, because behavior may not match what validation covered. A beginner mistake is assuming that because the model performed well in testing, it will perform well everywhere. Risk-based oversight treats new or uncertain contexts as higher risk until evidence shows otherwise. This approach keeps the system useful while protecting against overconfidence in unproven conditions. Oversight can be designed at different points in the workflow, and this is where architecture thinking becomes practical. One pattern is pre-output review, where a human must approve an output before it is sent externally or before it triggers an action. This is useful for high-impact communications or decisions because it prevents harm from reaching the outside world. Another pattern is post-output review, where outputs are delivered quickly but sampled and reviewed later to detect issues and improve controls. This is useful for lower-risk tasks where speed matters and the harm of a single output is limited. Another pattern is exception-based review, where the system routes only certain cases to humans, such as when confidence is low, when sensitive topics appear, or when policy boundaries are approached. Beginners should understand that oversight is not one design. It is a set of choices about where humans add the most safety per unit of effort. The best design uses a mix of these patterns so oversight is both effective and sustainable. To make exception-based oversight work, you need clear triggers, because vague triggers create either too many reviews or too few. Triggers can be based on the content of the request, the presence of sensitive data, the type of action the output would cause, or the user role and context. Triggers can also be based on system signals, such as repeated probing behavior, sudden spikes in usage, or patterns associated with misuse. The idea is that oversight should activate when the probability or impact of harm rises. For beginners, it helps to think of a smoke detector. You do not ask a human to stare at the air all day, but you do want a detector that alerts a human when smoke appears. Similarly, risk-based oversight uses automated detection and policy logic to bring humans in when attention is needed. This keeps the system useful because most routine cases flow without delay while still protecting against the cases that matter most. Human oversight also requires clear roles because not every human reviewer should make every decision. In many organizations, there are different levels of oversight responsibility. A frontline reviewer might check for obvious errors and tone issues in customer messages. A subject matter reviewer might check technical accuracy for specialized advice. A compliance or privacy reviewer might handle cases involving personal data or regulated content. An incident responder might handle cases that look like misuse or attack behavior. Beginners sometimes assume one person can be the human in the loop for everything, but that tends to fail because expertise is limited and fatigue sets in. Risk-based oversight assigns the right human role to the right kind of risk. This increases safety and also increases efficiency because reviewers focus on what they are equipped to evaluate. Oversight must also be designed to avoid creating a false sense of safety. If humans review too quickly or without guidance, review becomes rubber stamping. If reviewers are overwhelmed by volume, they may miss subtle problems or default to approving everything to keep work moving. This is why oversight design should include decision support, such as clear criteria for what to approve, what to reject, and what to escalate. Reviewers should understand the system's limitations and the common failure modes so they know what to watch for. Oversight should also include feedback loops so reviewer insights are used to improve prompts, tune controls, and update validation tests. Beginners should see oversight as a system, not a person, because a person without criteria and feedback is not a reliable control. A reliable control is one that produces consistent decisions and leads to measurable improvement over time. Another key oversight concept is accountability, meaning decisions must be traceable to responsible humans. If an AI system causes harm, the organization should be able to determine how the output was generated, who approved the relevant use, and what controls were expected to prevent the harm. Accountability does not mean blaming individuals for every mistake. It means ensuring there is clear ownership of the oversight process. This includes documenting what kinds of uses are permitted, what oversight is required, and what evidence shows oversight happened. Accountability also requires that people are empowered to stop risky actions, because oversight without authority is only observation. Beginners should understand that accountability is part of safety because it prevents organizations from treating AI as an unaccountable actor. When responsibility is clear, improvements happen faster and risky uses are less likely to slip through. Oversight also interacts with user experience, and this is where risk-based design protects usefulness. If oversight is too strict, users may become frustrated and seek workarounds, which can create shadow systems and increase risk. If oversight is too loose, harmful outputs may reach users and erode trust. Risk-based oversight aims for a middle path by preserving fast paths for low-risk tasks while adding friction only where it prevents meaningful harm. This can be done by limiting which features are available in which contexts, by requiring approval for certain actions, or by sampling outputs for review rather than blocking everything. Beginners should recognize that safety and usability are connected. A system that is safe but unusable will not be used correctly, and incorrect use can be unsafe. Oversight must therefore be designed as part of the user journey, not as a bolt-on gate that ignores how people actually work. A mature oversight program also evolves as evidence accumulates. In early stages, when uncertainty is high, you may use stronger oversight, such as more frequent review or narrower permitted uses. As you collect validation results and operational monitoring evidence, you can adjust oversight, perhaps allowing more automation for tasks that show consistent safe performance. Conversely, if incidents or near misses occur, you may increase oversight, tighten triggers, or restrict certain features until controls improve. This adaptability is essential because AI systems change and user behavior changes. Risk-based oversight is therefore not a single design decision. It is a living control that is tuned based on observed risk. Beginners should see this as a learning loop, where oversight decisions are refined over time to balance safety and usefulness. This also supports governance because leaders can see that the organization is managing risk actively rather than setting a rule once and ignoring reality. To close, designing risk-based human oversight so AI stays safe and useful means placing humans where they reduce the most harm without blocking routine value. You classify risk based on consequences, uncertainty, and context, and you design oversight patterns like pre-output review, post-output sampling, and exception-based escalation. You define clear triggers so humans are involved when risk rises, and you assign the right human roles to the right decisions so reviews are informed and consistent. You support reviewers with criteria and feedback loops, so oversight becomes a reliable control rather than a rubber stamp. Finally, you treat oversight as adaptive, tightening or relaxing based on evidence as models, data, and threats change. Task 20 is ultimately about building a system where humans and AI work together responsibly, with accountability and safety built into the workflow instead of being left to hope and good intentions.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.